All right, so what we're going to talk about, we talked about deductive reasoning. That's what we use when we do a proof. We look at what we have, and based on evidence through postulates, properties, theorems, corollaries, definitions, we can step by step make our way from a beginning to a conclusion. That's deductive. It's all based on evidence. But what I want to talk to you about today is the let's jump to a conclusion reasoning, and that's called inductive reasoning. And a lot of us are skilled, and some of us are not so skilled, but still try to use it. Inductive reasoning. Now, we should already have a vocab card for deductive reasoning. Yes? Okay. So what I'm going to do is go through it again, but that doesn't mean you make a second card of it again, okay? So inductive reasoning, this is, by the way, lesson 3-6, so good idea to read this in the book. And so let's talk about deductive. Just to remind ourselves, deductive reasoning. So deductive reasoning is proving statements by reasoning via accepted postulates. Now, the reason why I use the word accepted with the postulates is that some people kind of create their own ideas and then say, oh, that should be a postulate. I get that one all the time. Whoa, we should make that a postulate. That way I don't have to write stuff out. We should give it a name, and then I don't have to write anything. By the way, still, people on the Chapter 3 quiz were writing like Theorem 3-6 as the reason. 3-6 means nothing, okay? If it doesn't have an accepted name, 3-6 is not a name, it's an identifier where it shows up in the chapter, then you don't get full credit. In fact, you get very little credit for doing that. So, proving statements by reasoning via accepted postulates, definitions, so not your version, but what's accepted, what's in the glossary, theorems. But as we found out in that video, or not the video, but that assembly we had with media, that social media, that Wikipedia, I didn't realize that. Well, yes, I knew people put garbage on the internet and speak very authoritatively, so it sounds like they know what they're talking about. But Wikipedia, I did not realize you could actually change it. You can edit what's in Wikipedia and then save it, and that's what everybody else will read, is your edited, saved version. And so I thought, oh, that is nothing. Don't ever quote Wikipedia on anything. Sorry, Wikipedia. Theorems and given information. Sometimes, remember, the given information is in the diagram, you notice something that you can use in conjunction with your theorem. For example, oh, you've got two vertical angles that are, and you know from Theorem 2-3 that they are congruent. So, but you saw the relationship in the diagram. But the theorem supports the relationship, okay? Just looking at it, you say, I have vertical angles. The definition of vertical angles are two angles with a common endpoint, but whose sides are opposite rays. That says nothing about that they're going to be having the same measure, okay? Only the theorem states that, okay? Now, with deductive reasoning, conclusion must be true if the hypothesis is true. That's where we're having breakdown when you guys are working on your proofs, is that your conclusions are false. But it's based on a true hypothesis, because you're going down a path that doesn't make sense. By the way, if you birdwalk yourself, which happens when you're doing a proof, you've put something in and you realize, hey, I don't really need that, you can erase it and take it out. Okay? There's several people that put some information once and never used it again. Okay? Don't keep it in the proof. Right? Got to remove it. So that's deductive reasoning. Keyword is evidence. Evidence that's verifiable. Okay? So deductive reasoning is evidence. It's verifiable. All right, you ready for the next one? The other type of reasoning is inductive reasoning, the one our title of our notes. An inductive reasoning is that the conclusion is based on several past keyword observations. Conclusion is based on several past observations. No evidence is gathered, it's merely observed. So it has to deal with just viewing this. And based on your viewing this, you come to a conclusion. Now, the conclusion is probably true. But not necessarily true. It's not mandated to be true. Whereas in deductive, it must be true. Okay? When you're doing inductive reasoning, I'm a queen of this. When I was your age and even through high school, it was only in college that I actually developed my voice. I always had it at home. I'm sure some of you are like that, where you're really quiet at school and then you get home and you're like, bleh. I'm like that. Because my parents would go to the parent conferences and they would say, your daughter's so quiet in class. And they're like, wait a second, Marta, you're talking about my daughter? Marta, no, she's not quiet. She never shuts up at home. Okay, my daughter never shuts up anywhere. So her behavior is consistent wherever she is, right? But I am those introverts. Introverts only open up to those people they feel comfortable with. And the rest of the time, they just shut their mouth and we watch. We're observers. And we're the people who notice details. And I would always, in high school, go, oh, Susie and Jim are dating. I'm like, how? Did you ask them? I'm like, no. Then how do you know? Do you see how they're sitting next to each other? They literally, their arms are touching. His head is touching her head as they're talking about something, and they're giggling. Okay, they like each other. And I'd have to say 99% of the time, I was right. My observation skills are so strong that when I lived in Europe, I don't speak every language that there is in Europe, and I don't even speak the ones that I do kind of know very well. You're very good, you're very beautiful, you're very tall. That's what I could say in German. But it worked. I could get through anything I needed to get through. My friends would tell me, we don't really feel comfortable talking in front of you because it's like you know what we're saying. But I observe body language. I observe tone. I observe the look on their face when they're talking. Now, I had some friends who were from Hungary, and they were particularly nervous around me. But I said, you guys talk about two things, vodka and sex. So I pretty much know exactly what you're going to be talking about. And they went, oh. Because I had observed them enough that I could figure out what was going on. And I'm one of those people that I know a little bit of a lot of languages, and I can pick up a word here and there, and then I, using my inductive reasoning, put 2 and 2 together and come up with 4, though sometimes I come up with 6. One day I'll have to tell you my Spanish episode, but not on tape. So, inductive reasoning is, here's a really easy one for inductive reasoning. Johnny observed that for the last 3 Wednesdays, chicken nuggets were served at lunch. So he asked his mom for money so that he could buy lunch this Wednesday because he knows that there's going to be chicken nuggets. Now, Johnny doesn't know for sure there's going to be chicken nuggets. Johnny did not get evidence. He didn't go, and he didn't go to the menu. He didn't go online. He didn't look at what was being served. He just made an assumption based on his observation. Okay? Assuming can be a problem. And with Susie, on the other hand, really likes chicken nuggets. So Susie had gone through the menu for 4 months out and had highlighted every time chicken nuggets were coming. So Susie knew that this Wednesday they were going to be serving chicken nuggets because she'd already highlighted this because of the district calendar that was posted, and she got money from her mom and she was able to get her chicken nuggets. So the difference is evidence versus assumptions. So keyword here, assumptions. Now, what we tend to do is we make an assumption and then we may, after the fact, test it out. So if you think about science, you're doing inductive reasoning in the beginning. You're creating a hypothesis and a hopeful conclusion, or from a hypothesis you come up with a conclusion. Then you start gathering evidence, and based on that evidence, now you make a decision whether you were correct or incorrect in your assumptions. Your assumption now becomes evidence and now becomes deductive at the end. Rachel?
Is inductive reasoning kind of like an educated guess?
It is like an educated guess, okay? Guess and check when you were younger. That seemed to be the only strategy they used to help solve for the mystery. And now we've learned a ton of tricks and processes in algebra class. How can we actually do it? But here is probably the most common way that we use inductive reasoning in mathematics, and that would be patterns. So in patterns, what you're looking for is you're trying to come up with what did they do to get from the first number to the second number, and is that reproduced from the second number to the third number, and the third number to the fourth number, and so on and so forth. So that's how you guys have somewhat developed your inductive reasoning skills, is through the use of patterns. So we're going to practice that. So find the next value in the sequence. So first, we've got 3, 6, 12, 24. So the first thing our eye does is it looks at the pattern and says, is it increasing or decreasing? Increasing. What operations allow numbers to increase? Adding and multiplying. So those are our two options, is to see, do we have an adding pattern or do we have a multiplying pattern? Now, pattern means same thing every time. So if we start and we say, okay, I think this is an adding pattern. To go from 3 to 6, I would add 3. To go from 6 to 12, I would add 6. So if you notice, this pattern isn't working because it's not the same thing over and over again. So let's try a multiplication pattern. So let's see, 3 times 2 is 6. If I multiply 6 times 2, I do get 12. If I multiply 12 times 2, I get 24. So based on that observation, I'm able to come up with what I think would be the pattern. So I'm going to multiply the 24 by 2, and that's where the 48 comes from. Next, how about 11, 15, 19, 23. So again, my numbers are increasing, so the only two choices for patterns are adding or multiplying. That's generally how we start. So let's try adding first. See, 11 plus 4 equals 15. If I add 4 to 15, I do get 19. If I add 4 to 19, I do get 23. So I got the pattern off at the very first time. So the next number in the sequence, I would add 4 to the other number, and that would get me to 27. Okay? But sometimes the pattern is a little strange. I have 5, I have 6, I have 8, I have 11, I have 15, and we want to know what the next one would be. And so actually I'm going to go back and change these guys. Oops. So my numbers are increasing, so first thing I'm going to do is look for a pattern. So here I add 1, here I add 2, I add 3 between 8 and 11, I add 4. So I'm not adding the same thing, but look what happens if you take the pattern one level more. This is adding 1 to this one, adding 1, adding 1. So I eventually can end up getting the same pattern. So instead of adding the same number every time, I'm adding a number that increases by 1. So 1 more than 4 would be 5, and then that would give me a number 20. Alright, so let's do a couple of tricky ones. What if they don't have, let's see, this is 4. Numbers. So we got J, F, M, A, M. And my job is trying to figure out what do those letters represent. If you think about it, in our life we have months: January, February, March, April, May. So the next would have to be June. Alright, we've got one more. Oops. Try to mess with your mind. O, T, T, F, F, and what would come next? So again, we think of words that might have something to do with what we're used to. What about the numbers? 1, 2, 3, 4, 5. So our number would be 6. And that would start with the letter S. Alright, good luck.